Welcome to our lesson on tree diagrams. So we'll start by just answering this question. Determine the number of methods of traveling from Toronto to Washington via New York if you go from Toronto to New York by either plane or bus, and then from New York to Washington by plane, bus, or train. So we're going to answer this question using what we call a tree diagram. So a tree diagram is pink. A tree diagram is going to help us illustrate how many different ways we could go. So what a tree diagram is good for is when you're performing multiple actions in succession. So in this case, we have two actions we have to perform. We have to perform the action of going from Toronto to New York. Toronto to New York. And then the second action is going from New York to Washington. And then we perform those two actions back to back, which takes us from Toronto all the way to Washington. So we know that there's two ways to do this action and three ways to do this action. But we want to know how many ways there are to do both actions together. So what we're going to do is a tree diagram. So the first thing you do when doing a tree diagram is you look at action 1. So you list the possibilities or the two methods you could use to do action 1. So for action 1, we have we can go by plane or by, I believe it was bus. Yes. Bus. So this will get us from Toronto to New York. So this is action 1. Action 2, we have three options. So from each of the actions in action 1, we're going to start a branch, sort of the branch of your tree, to illustrate action 2. So I could go by, for action 2, I could go by plane. I could go by bus, or I could go by train. So if I took the plane from Toronto to New York, I could then take a plane from New York to Washington, or a bus, or a train. And then the same thing from this branch. I can go by plane, bus, or train. So in total, I have 1 method, 2 methods, 3 methods, 4, 5, or 6. So there are 6 methods for me to travel all the way from Toronto to Washington via New York. This first method, we could call that the plane method. So that means you're taking a plane both times. The plane bus method. The plane train method. The bus plane method, the bus, and the bus train. So all of these are different. Notice these two, the plane bus and the bus plane, are different. Even though you're taking a plane and a bus in both, the order matters. So when doing a tree diagram, it's very important to note that order of actions matters. Okay, so even though we're taking a plane and a bus in both cases, we're taking, in this one, we're taking the plane from Toronto to New York and the bus from New York to Washington, and vice versa in this second method. And then your overall answer, therefore, there are 6 methods. Okay, now we'll look at a second example. This one's slightly different. Suppose you flip a coin. I'm going to change this to 4 times, and you're going to see why when we do this. 5 would just be sort of too much to draw. So we're going to flip a coin 4 times, and we want to determine the number of ways you could toss exactly 3 heads. So again, we're performing multiple actions. How many actions? We're tossing the coin 4 times, so there's 4 actions. Action 1 is first toss. Action 2, second toss, and then action 3 and action 4, the third and the fourth toss. So for action 1, to do your tree diagram, you're going to list all the possibilities for action 1. Well, if you toss a coin, there's only 2 sort of possibilities, or 2 things that could happen. You could have a head, or you could have a tail. So it's action 1. Action 2, you're going to toss the coin again. So how many possibilities do you have? Again, 2. You can get a head, or you can get a tail. Head, tail. So in the first toss, you had 2 possible outcomes. If you combine the first and the second toss, you now have 4 possible outcomes. 1, 2, 3, 4. Now we're going to toss it a third time. So again, head, tail, head, tail, head, tail, head, tail. Count these up. We've got 8 possibilities. So the first 3 tosses, you have 8 possibilities. And then a 4th time, head, tail, head, tail, head. So from each of the previous possibilities, you need to list the outcomes for this 4th action. So there's 2 branches from every previous outcome. Okay, so count these up. There are how many total possibilities if you toss a coin 4 times? Count them up. Therefore, there are 16 possible outcomes. So what were they? Well, this top branch of the tree, you had a head, then a head, then a head, then a head. So this was the head, 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 head. You had 4 heads. The sort of second branch down, head, 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 tail. So 3 heads and a tail. Head, head, tail, head. So etc. And you could list all these 16 outcomes out this way. Now remember what the question was. We wanted to determine the number of ways you can toss exactly 3 heads. So we want all the outcomes with 3 heads. There's different ways to kind of figure this out. Basically, we have to figure out all the branches that have 3 H's. So this branch here, right? 1, 2, 3, and a tail. That one worked. This branch here. So this was head, 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 tail. Head, head, tail, head. I would only have 2. Here's one. Head, tail, head, head. There we go. That'll be all there. Tail, head, head. So there's another one. And I believe that's all. So all the other ones have more than 3 heads, or fewer than 3 heads. Notice this one doesn't count, the 4 heads, because it said we had to have exactly 3 heads. So even though this has 3 heads, it doesn't have exactly, it has 4 heads. So therefore, there are 4 outcomes with 3 heads. So notice we're using the tree diagram for a slightly different purpose than in the first example. In the first example, we created the tree diagram to figure out how many branches were in the tree. And in the second diagram, we created the tree diagram and then we counted specific branches in the tree. So both different uses for a tree diagram. And we'll do one more example. Okay, final example. Suppose the Toronto Maple Leafs and the Montreal Canadiens are playing a best 2-3 game series. How many ways can Leafs win the series? So you win the series if you win 2 games, and you can play a possibility of 3 games. And okay, if you're objecting that in hockey they play a best 4 out of 7, that's true, but I don't want to do a diagram where there's 7 games. So we're going to go best 2 out of 3. So first question would be, how many actions are there? How many actions, or what are the actions in this case? And the actions are the games being played. So you could play you could play as many as 3 games. So is 3 the answer? And the answer would be no, not necessarily, because in this case you could play just 2 games, right? If Toronto wins the first 2 games, then the series is over. You wouldn't play the 3rd game. So in this case, there's 3 or 2 games, or 2 or 3 games. So that's going to make our tree, or our tree diagram, look a little different because you won't necessarily have the 3 branches. You might only have 2. But we'll start it just the same way. So action 1, W will be for a Toronto win, L will be for a Toronto loss. So what are the 2 outcomes? They could win or they could lose. They can't tie because we'll assume it's the playoffs where you can't tie. They'd go to overtime and you have to win. There has to be a winner. So there's 2 possible outcomes, win or lose. The second game, they could win or they could lose. They could win or they could lose. So now the third outcome, or third action, here's where it's going to get a little different. Notice this branch right here, win-win. The series is over. Toronto won 2 in a row, so they wouldn't play a 3rd game. So we don't need a branch coming out of this one. We just need the branch coming out of this one. So they could win or lose. Loss, win, they would play another game, so they could win or they could lose. And again, this branch here, well, they've lost 2 games, they can no longer win the series. They wouldn't play a 3rd game, so we don't need branches coming out of here. So we need to figure out how many of these ways did they win? How many were there 2 wins? Well, this one had 2 wins, right? This one here, they lose. Win, lose, lose. So that's no good. And then this one, they win. And then the other one, they lose. So they could win, lose, win, or lose, win, win. And let's not forget this top one too, where they won, and then they stopped. So therefore, there are 3 ways. Good. So they could win the first 2, they could win the first, lose the second, win the third, lose the first, and then win the next 2. And those are the only 3 ways they can win the series. So another sort of variation on our tree diagrams.